Hello, my name is Richard Seymour. I'm a programmer. I am in my third year at the University of Bolton. My portfolio link should be in the description below, along with my contact information. If anyone's got a question, just drop me an email. I originally started this game prototype in Unreal 4, version 4.4.3. 4.5 came out during the development of this prototype, but I didn't see a large reason to move from 4.4.3 to 4.5, as there weren't many advantages to doing so. But with 4.6 coming out soon, and the changes, my idea was to create a simulation of an alien colony that would behave like an ant colony. It would have a queen, and the queen would spawn drones, and the drones would then forage for food, bring the food back to the queen, who would then spawn more drones. The player I wanted the player to be able to drop in little food blocks into the simulation to help them along. But I wanted the player to be able to visualize the way the food blocks are for the ants. So after researching a technique called influence mapping, I was able to paint the scent trail that the food might give off for an ant. If you're watching this video just to see how you might code in Influence Map, or generally see my project inside Unreal, please skip ahead to the time below. If you're here to see my work process as well as how I may have coded it and how I might code it in the future, I recommend you watch the whole video. I created a Trello board. I created a list of features, broad features I wanted in my game, and I color-coded them onto what I wanted definitely in the prototype, which would be green, in at least a raw form, yellow, which I was hoping I'd find time to put inside the prototype, and red I knew would probably not make it into the prototype. Along the way I might chart bugs and put them in the fix section if they were important enough to have a look at, and any research I did I kept references for. As I was doing a task in specific, such as influence mapping, I might split it up into separate parts on a checklist. Although some things took much longer than others on the checklist, it helped quite a lot splitting a single larger task up into some smaller ones, again quite broad smaller ones. Originally for version control I was using GitHub, which is where I got the Unreal 4 source code from. It was quite bad at handling larger files, and the project files got quite large, so I ended up switching to SourceTree, which, as it's pushing, chunks those files. And I created a repository on Bitbucket. Early on, I didn't numerically put down the way that each progression or version, but just gave a small comment because even up till this point I was constantly moving between repos and trying different techniques and different ways of, especially the graphical side of it, of playing with the code. When I started to have more solid versions, I moved it onto one repo on 18th of November, and as I got towards the end of what I felt was getting quite close to the way the prototype should be, I started to numerically order it, 0.1 being when I got influence mapping working as intended, and 0.1.1 onwards, and 0.1.2, which would be the current one, I got a bit more detailed with the changes I was making, because they were more minute and less subject to large change. In UML, I created a draft for how I wanted this to turn out when I started. This was based on me doing it almost entirely in code, with maybe a few things run up into the blueprints in the editor, calling a few of the functions in the blueprint. I wanted the influence map to have the mesh, and to have it basically be an actor, and it would use the tick and post-initialized components functions that come with being an actor, and just generally draw influence on the world by creating a texture. I've added a lot of members now, but originally I had planned to just do a few things like a small pointer here to data influence map. data influence map and cell influence didn't really need to be actors because they were going to be run up to here anyway, and then they'd be ticking and use their functions in post distress components anyway, so they only really need to be on Unreal class or an Unreal object. Decided to make them Unreal objects, and I've almost stayed exactly where I planned to, the way I planned to do them. Originally I was going to do recursion for my propagating of influence, as I spoke about, but I moved on to doing a different method instead. I've also padded this out into a lot of extra functions. I was going to have a quick food one, and maybe later on this, if I had time, could be several different types of food, but I basically wanted a small integer for the amount of food, or float, and then we make a mesh depending on the size of the amount of food. I don't think this was incredibly high priority, just if I ever get time to come and improve this for the player, I might do that. And for the AI, I had planned to do it a lot more in code, but because Unreal has a lot of tools for AI inside Blueprint, it has the behavior tree and the blackboard. I might do a little more of it up in Blueprint and in the blackboard and the behavior tree. But originally, if I was just wanting to create them as characters for the controller to use, I was going to have a controller which would have a factory creator, which should be implemented and would spawn a queen, a drone, or a soldier, and the queen might or might not be a singleton. The colony controller would inherit from Unreal AI controller, which would then control a character, which would be this is an abstract class which these inherit from, so it might have some functions such as pathfinding inbuilt into it. I didn't want to plan this out too much because I was sure I might change it quite a lot before the final version. But yeah, this inherits from Unreal character, and then they all run up to the blueprints in the editor, was how I planned it. Or perhaps a fat class, which has everything inside it, called game class, and then that would be run as a whole blueprint. Thank you very much for watching. For my prototype, I wanted to have a block, energy block or food block, that would put influence out onto the world and paint it on the map visually for the player. I wanted a graph to be drawn so it'd be nice and easy to see where it's being painted over. I wanted the AI in a quite raw form at this point to seek the epicenter of the influence. I wanted it to follow something like a centriole towards the location. So press play. See, once the influence reaches the queen, she'll move towards the epicenter of its being painted across the world as it goes outwards and decays from the signal point. I can move this along, and it will change where the influence is being painted from. It's not in the middle because it's decided on about where the cell, where the block is in conjunction to what cell it's inside, and it will paint out from there. It's not 100% accurate because when we do a float to integer conversion, it's using truecanting. So if I keep moving it towards an edge, see, maybe it should be in the other one by now, but if I move it over, it definitely should be in the other one, but instead it's inside the previous one, because if it's on something like 1.9, it knocks it off down to 1 instead of rounding it, which is something I might have to work on. In the blueprint, I've got a very simple behavior tree for moving towards the highest influence point, which is a vector. It's calculated inside the queen blueprint. What we do is we do the getPath function, which is from the main floor, which is the floor itself, which has the influence data on it. This is my own function that I've created, made blueprint callable. I've got the actor, which is the queen, and given it the x and y values, and then it will return the vector of the calculated middle position of the cell with the highest influence from where it is currently. And then I set the value as a literal name inside the blackboard, which then goes into the behavior tree. inside energy block. Again, this is my own function that I've made to be able to callable on Blueprint. Again, getting the influence and the actor location, and then putting it into the world with the influence value of 200. This might be randomized in the future, which might change the size of the food block. Or the food block size would influence the influence value. Originally, a lot of these functions and stuff were especially for the graphics, were run more in Blueprint. But as I'll get into later in the code, I found some bugs passing values, especially textures, in between Blueprint and the code in Blueprint. So I had to run most of it inside the code instead for the graphical end of it, which I'll get into next. I'm about to go into depth about how I have coded the C++ influence map and the data for the influence map inside the Unreal Engine. If you're uninterested in this, please skip to the time below. Inside Microsoft Visual Studio, we create the mesh and make it a uProperty. We create a pointer, which is a material instance dynamic pointer. Originally, I had the material created inside of Blueprint, but because of some errors when passing the texture up as a texture parameter into Blueprint, it was being converted into a 16 by 16 image from what was originally a 512, but 512 by 512. It was being converted to a 16 by 16 and having very, very strange memory values. It was halving in the X direction and doubling in the Y in the sense that it was putting spaces in between. It was very confusing, but moving it down into the code made it work. I reported it as a bug. As the texture that we'll be using to paint the pixel values on. This is my own custom class, which has the data and does most of the data end of stuff on the influence for each cell. uint32 is the cell size. This changes the size of the cells, so as 64 would be larger cells and 32 would be smaller. For example, making this 32. There's a lot more cells. Originally I was running on 32, but because of some of my functions being a little inefficient right now, the frame rate was dropping a bit too much, so I moved it up to 64, which increased it quite a lot. I might drop it down to 32 again when, or maybe even lower, when some functions are much more efficient. The Blueprint callable set influence from location this is the function being called by our energy block. I get the X and Y values, finds out where they are, and finds out the cell it's on, and then puts that amount of influence into the cell, which then will then propagate automatically. Get the cell path point is for the queen, or the AI in general. It's going to get, by inputting those two variables, it's going to return the vector of the location it should go to next. This is the middle of the cell with the highest influence from the cells around the cell it's currently on. And then I ran an override for tick and post-initialized components. I'm about to go into depth on the functions for the influence map class. If you are just here for a broad overview on how someone might code this, please skip ahead to the next header, which is at the time below. I quickly just create the root object as the floor plane, turn on the actor tick and has it start with it, and set the cell size to 64. I access the graph map from the texture. Uh, it's just the texture as first map. Um, the raw image data, I get the book data as a reference, and then I get the formatted image data and cast it. And lock read write means I'm going to be changing it. It's locked now, so nothing else can change it. Set the texture width and the texture height here. Give some values for me to use. Texture color is the one I'm just painting it green basically. Color world just paints everything green. It goes. I use these kind of things quite a lot. It's basically just drawing a row, and then painting another row, and then another row. I have pixel y times texture width plus pixel x because it's stored as a one-dimensional array, the pixels, and as each row goes. So pixel y times texture width. If that was 0, it would be on row 0. If it was 1, it'd be on row 2. Then make it pixel color, which is just green. I draw a graph over it and add in the increments of the row differences, the row sizes, and paint them black. Make sure the cell width in between them is the part that's being calculated and not in between. I basically calculate the two x's plus I calculate the first one, and I calculate the one with the added on cell value, and then I'll calculate the y. So I'll propagate influence automatically. Currently passing it the map and some other values which are no longer being used currently but might be in the future, so I'm keeping the parameters in the function for now. I automatically fill the influence of the map. This basically just looks for influence and then paints it, but this is where the data of the influence is calculated. This is a debug function, just so I can follow stuff in the output log. Update the resource, this is important, and then set the texture parameter value to texture. In posting this as components, this is straight after the constructor. If the floor plane is not equal to null, create and set. If it doesn't exist, but it should exist because I made it in the constructor, set the material on it to be equal to the material that we create. This is basically getting the texture here, which you use the texture, the new texture create transient function 512 by 512, and then we force the material graph to be to the texture. This is where we create the data for my own custom function, so for class. Create the new object because it's an object class inside Unreal because it's quite specialized. I didn't feel like it should be an actor. Data influence map, this is a function inside it. We'll go into these later, but I had to separate some of the stuff down, like create memory and set the cell codes and inside, because I can't pass some of these things down in a parameter in a constructor because of the way Unreal is in this version. Set influence from location. If we look into more detail on this is again the function being called by my energy block or foo block. We get the cell number from the x and y location using return cell from location. And I mean this here could just be inside here, but this I like to split things down for breakpoints, especially in these early phases, to be able to follow along what's happening. I set the influence from a specific cell, which is gotten here, to the influence value, which is gotten here. So I'll go into how this works later. I get the path point. Again, I've done what I've done up here. I've split it up so I can follow along what's going on. The reason this check is here for get path point, this thing being called by the queen, is sometimes the physics will get really buggy and fling an object off, or be generally quite confused. So this was a really cheap and dirty way of making sure that cell number is actually a decent value. is actually a value which would be inside the array of the cells, because if it's not, then there's no reason for it to do this, and we've got just in case function here. But then we have another specialist function, which is get in the middle of the greatest influence from the cells around. This function I will go into a bit later, but basically you feed it the cell number, and it returns an f vector with the x and y of the middle of the cell with the greatest influence from the cell you're currently on, the cell. You can feed it as a parameter. And next I'll go into the data influence class. Just quickly before I touch on the data influence graph, I want to look at the cell influence map, which is basically has a bunch of private member variables which have get and set functions, and has a cell number which is public. This is going to be the cell number it is. Min x and max x and min y and max y are essentially the coordinate values for the minimum and the maximum, almost creating like a box. So down here would be min x, and up there would be max x, and max x, y will be up here, and min y will be up here. So we can calculate it on something like a 3D environment, or on a 2D environment. Right now, influence is a uint32. This is quite cheaty, because as it gets closer to 0, it just becomes 0, which means things, if they decay enough, or if it becomes really close to 0, it just true cants down to an actual 0. If it's 0 point something, when it's a float up ahead. This is quite convenient, just because otherwise the whole graph will be filled with really low 0 point values, even though there's a decay rate. Later on, this will be changed to a float though. To look inside data influence graph, we have a lot of functions and generally a lot of variables as well. We have the propagate influence variable, which I mentioned before. We're feeding it these parameters that aren't completely necessary right now, but are there because legacy, they were there before, and they might be used in the future, so there's no point in changing it. There's a variable for if it can decay or not. I don't think this is being used right now, but it may be in the future. Again, void update. I don't think this is being used right now, but it still might be in the future. Get cells around is a function I've written, so when you input the number of the cell, you will get the cells around that specific cell. I really don't like the way I've done this because it's horribly inefficient, but I would like a minimum to store the cells around pointers, which it returns an array of the cells. I would really like to be able to store this inside the cells itself instead of on the fly in stack, because it will lower frame rate by quite a lot, especially with how bad it is, the current function. We'll show you when we get into it. The fill cell function, you give it a cell and you give it a color and you give it a bitmap, and it will fill that specific section of the map. It will paint a block of the color you feed it, which would be edited by our influence on the specific cell. The cell size and row number are set at the very beginning. The cell size is the size of the cells as it was before. Row number is the size of the whole, the texture, divided by cell size, so we can know how many cells are inside a row. It's quite convenient. Here we have the set cell size function, which is called very early on, so we can set. I'll show you later. Set cell coords sets the basic positions for everything. So 1 would be 0, 0. On a 64 size thing, it would be 64, 0 on the next one, which would be 0, 1 inside the array, which we get to next. This is the main array called cell. It's not the best name, but maybe later on I'll make it easier to understand. And these are the two cell buffers that we pass the influence back in between, depending on which one's currently going to be affecting cell. Cell is what's painted on the world, but these two basically just pass influence variations in between each other, so it's not lost, so it can be saved and tracked. Uh, this is this helps the buffer in between. Create memory is a function for basically just creating all the pointers using the Unreal method. I'll show you later. Fill influence fills the whole map with the influence values. If it will call the fill cell function on the specific cells that because it goes through every cell, and if it has influence, it will draw influence. Calculate propagation. This is called a redic. Takes the source and destination, cell buffer and cell buffer 2 is the two sources of the two arrays that it will pass in between. It will pass in between depending on which one was done last, basically. So it's always saved. This is, I'll go into more detail later. Copying the influence, you just get, again, you give it one array, give it another array, copies the influence in one into the other. Originally, I was using a different method for this. I was just copying the, I was just saying this array is equal to that array, but for some reason that says this memory is equal to that memory, and instead of copying the actual data inside, it just says, no, I'm pointing over there now. Set influence cell is, we set the influence on a specific cell number with a float value. This is a function for debugging. Just prints in like a grid type format the influence. Return cells from location, talked about this before, and get influence from cells around. Not the best name ever. These variables are just quickly used by the get cells around function. I moved them up here, but they were fine down in the function themselves. I'm about to go into depth on how I would code the data for the influence map. If you're uninterested in looking at the details of the functions, please skip ahead to the time below. Go to the very top, very beginning. I'm going to get cell size set 0, row number set 0, count decay set to false. So I create the memory. What I do is I get, originally when I'm setting size, cell size, we're setting the cell size and the row number, and as I showed you before, it's 5, because it is the size 512 is the size of the texture. It's that divided by the cell size is equal to the row number, which is 16. So this would be 16 by 16, which is the amount of cells there will be. Create a cell in all of them, create a cell in all of them, create a cell in all of them. This is for the buffers and the cells. Originally, I just had it so the cell buffer would equal to this, but that would, instead of making its own memory with the exact same values, create a point. It would just make all the pointers over here point to the same memory, so I had to create them separately. I really don't like doing it this way, and in 4.6 apparently they're making a lot of changes that might make this kind of horrible thing go away, but for now it's kind of necessary. Although I might be wrong. Set cell coords, we go through each of the locations inside cell, and we set the min x times the I, min y times the j. So where we are, max, and that's +1 because we want it to be plus whatever the cell size was, times, so it would be plus, and this would be 64 on the first one, double 64 on the next, and 3 times, but this would always be 1 over because it'd be the next one. Set the influence to 0 by default, and then we give it the cell number, and again this is a one-dimensional array again, so what we're doing is we're adding I to the row number times the amount of row, what row number we are on, and that's the row size, and then we basically have a cell number which is public, where we store this data for what cell number we are on inside the cell itself. I set buffer equal to false, I'll show you why later. Copy influence from the cell, cell 1, cell 1, cell 2. Again, originally I had it so it was just saying cell is equal to cell buffer 1, but it doesn't copy the data. It just says points over there. So maybe I'm doing it wrong, but it's just easier to create my own custom function and copy all the influence over, because it doesn't need any of these anyway. It just needs the influence itself for calculating. I'll show you the copy influence function in a sec. Fill cell, we get the mipmap, we lock it. We get basically it's the same as before when we were drawing on the whole 512 by 512, but instead we're pinpointing a 64 by 64 or 32 by 32, depending on the cell size. We're pinpointing exactly where we want it, so we get the pixel Y times by the cell size and row number, and then we add the pixel X. This will paint a square onto the entire thing of the color we choose. I unlock the data. This is the get cells around function, and this is the first thing I'll probably be changing in the future, because it is pretty horribly inefficient. And if it's going to have to be this efficient, I'd rather it was only run once. I'd like it if you could just store the cells around and on the cell itself. But for now I've done it this way, so it's mostly calculated on the fly. Quickly get the values that would be from the cell that we're on. We go get the cell, get the X of it, minus that, and that's what the same value would be on the left. And then we run a check on the entire array. This is the problem, we run the check on the entire array instead of maybe pinpointing the exact ones that would actually be the right ones. We have to check the left X. There's a different parameter for each of them, but this will be the check for the left cell, right cell, up cell, down cell. And then slightly differently on the diagonals, because we have to calculate for left X, and instead of it just being the same on the Y value on this one and X value on another one, it would have to be both of them different. So we just use both of these. I then return it, but I really think this is the first thing I'd probably come back and change in the very near future. I calculate the propagation. I get the source and the destination. I'll quick go down to propagate influence so I can show you first. What we do in propagate influence is, again, ignoring the parameters, which aren't that necessary. We run a buffer. The buffer. No, we're not running a. We run a. It's a bad name, really. We say if it's equal to this time, run that one. If it's equal to this, run that one. And it's basically, is it going from cell buffer 1 into cell buffer 2, and then copying the influence from cell buffer 2 into cell 1, or is it going from cell 2 into cell buffer 2 into cell 1, and then copying the influence over? It's flip-flopping in between them. I've got some comments, because I'm sometimes checking the data on stuff, making sure everything's running properly. The really interesting thing is, originally I wasn't running this as two separate things. Originally I wasn't flip-flopping between two things which had the data stored always there in memory. Originally I was using recursion, so I called the same function on each of the cells around it until the influence was decayed down to 0 or less than 0. But I think I ran out of stack memory, because it basically gave some very, very buggy results. So if the influence value wasn't equal to 0, so it should just quit out here when it gets to too low, it would get the cells around, and then on each of the cells around run the same function after painting the value. But it didn't seem to it didn't seem to be able to calculate that many steps deeper on the third layer. It's 8 times 8 times 8 many times it's got to be running. It seemed to run out of memory. It seemed to get very buggy. It still ran, but it didn't run the way it was supposed to. And technically it wasn't the right way of doing it anyway, although it's slightly faster. This way it's much easier to debug, it's easier to track, it's more proper. If we go up to where we do calculate propagation, what we do is we get the source, which is in one case cell buffer 1 and in another case cell buffer 2. We get the influence of it, and we times it by, we get the influence propped, which is the amount we're pushing into every neighbour. And we go, get its own influence and times it by 0.3. This is the amount we're pushing into everyone. Influence from round cells is equal to 0. This is the amount we'll be getting from all the cells once we calculate it. get cells around very quickly. Again, I was quickly doing some error messages here earlier. Not error just easy logging stuff. Here I get the influence from the cells around, which is here. It's equal to itself, so it keeps adding on all the stuff it gets from its neighbours. It's times source cells. Basically, it pulls out 0.1 from everything, around it, which is the things that the neighbours are pushing into itself. So basically, it says, and then I empty the cell, empty the array, and set the influence on the destination, the new one, in the specific point in the array, to the source, get influence minus the influence propped. So this is the amount I will have pushed into other people theoretically, and influence from cells around. This is the amount I'm gaining from my neighbours. Later on, I want to make it so influence propped value and the amount I'm getting from the people, and also the decay rate, which is done here. I'll get into in a sec. We change that on the fly. I'd like to be able to move those values around inside on the editor, so maybe a designer could play with it. For now, it's kind of a bit hard coded. It's a bit raw. It's not very polished, but it will get there. For the decay, just quickly run everything, times it by, basically just it loses 30% of itself. Everything does. This theoretically should affect how far out it should be able to go before it becomes 0. I copy the influence from one thing to another in quite a few cases, because here in propagate influence again, I'll get the sub of 2, make that cell, because remember cell's one that's painted, and this doesn't really have any values, it's just got the influence. It's not got the data, so cell's the one that's painted later on. We get the destination and we get the source, and we just go through the whole array and then set the influence from one array to the influence on the other array. And I do that quite a lot, and again further up. Fill influence goes through the whole of cell, and if it's the cell it's currently on is greater than 0 on influence, it will fill the cell of the red value equal to the influence. So, and this is casted to a UN8, which is the number that the red would be. So if it's got 200 influence, which we saw before, if this is the main one, would be the very middle one. Is 200. It's quite vivid orange. This can go up to 255 at the highest for the float. But yeah, it's quite a nice way of showing that visually how the influence is less the further it goes, and how it sort of decays out. Set the influence on the cell. This is, we pinpoint a cell and we set the influence specifically on a cell, and then later on that might propagate outwards. So yeah, the propagate function itself doesn't push influence into something, it just gets the influence that's already there and then pushes it around and spreads it. We get, apologise, that's some stuff from before when I was checking data values. Again, we do another check because sometimes the physics engine can push something off the edge, it gets a very odd cell number and it bugs out and it crashes. So this is just sort of a safety parameter, quick, dirty, cheap and nasty one. Gets the cell buffer on 1 cell number, because it might be on either one in the tick because it's flip-flopping in between, and if it's not being set to the same on both of them, it's going to flicker and pulse in between the two different ones because it's not consistent. It's buggy, it's wrong. So at the same time we have to set it to 200 on both of them, and this is called every tick until the source of an influence might disappear. Return cell from location. Cell number found is the cell that we're returning. Xcheck is the X casted to a UN32 and Y casted to a UN32. so we can run a check because they are stored as uint32s. So it's important we keep the same data types. Run through the whole array, and we check each one and see if the min x is less than x check, and that the min y is less than x check. Sorry, y check, and that max x is greater. It's quickly just checking if its middle's in the middle. As I said before, this just knocks off the end. So if it's 1.9, it's going to go to 1. It's not going to round up. It should be rounding instead of truncating, but that's something I'll have to implement in the future. Maybe with fixed point integers being involved as well. Although I am skeptical about adding third-party libraries into the Unreal code, so I might have to write it all myself. Let me just return the cell we found. We get the middle of the greatest influence from the cells around, so we feed it a cell number, make a vector, we get the cells around again, make a float, influence check 0, middle of greatest influence is equal to 0 because we don't want him moving in the z direction, but we need a z direction, and we don't want this to be something random. We go through the whole of the array of the cells around. We do a check to see if it's less than the influence that we are currently on. It basically goes to each of them. If your influence is less than mine, you're not worth my time. But if your influence is greater, then we'll check here. Influence check is equal to cells around get influence. The influence check is now equal to the influence here. So it's going to go, when it goes through again, if the next influence isn't larger, then it's just going to stay as to where it is. The influence check will be the same. Middle of the greatest influence x and the middle of the greatest influence y. Just get the min x and min y. We add the cell size divided by 2, which if it's 64 will be 32. So we had 32, 32. So it should just always be in the middle. And we cast this to a float again. This should be pretty fine conversion wise. It shouldn't be that bad. Empty the cell and then return it. Very simple thing here to be able to track what's happening in the log. For example, I'll show you. Just so we can track the whole array on the row number. And when every time cells around is called, I want to print it to make sure that cells around is working properly because it is horribly inefficient. Afraid it's going to break things. But yeah, that's almost all the code. I did some small stuff with energy block. It's very simple in comparison. But yeah, that's how I've calculated. Thank you for watching. Again, if you have any questions, please feel free to contact me on my email address below, and I'll take a peek at my portfolio. Thank you very much.